Now that you've gotten used to the basics of trigonometry and hopefully you remember the right triangle, sine, cosine, and tangent, we are going to be learning about law of sines. But first off, we're going to do some bell work, making sure you remember how to do word problems, and then we're going to throw some stuff in the calculator and see what's going to bring us for today. So our first bell work is Shelley looked out the window at a statue and her angle of depression was 57 degrees. If she knows the window is 19 feet in the air, how far is the statue from the building Shelley is in? So we're going to say that this is her building, and we know it is 19 feet. She is looking out from the window at a statue down below. Her angle of depression is 57 degrees, and we want to know how far away the statue is from the building. So remember angle of depression. If we know angle of depression, we know angle of elevation because they have to be the same thing. So this helps us realize that since we know this angle and two other things, we can use sine, cosine, or tangent. So looking at what's been given to us from the angle of 57, we have 19 being opposite and x being adjacent. So that means we're using tangent. So we're going to say tangent of 57 equals opposite of our 19 over our adjacent of x. We're going to cross multiply so that x times tangent of 57 equals 19. So x has to equal 19 over the tangent of 57. Plug that into your calculator and you're going to see that it is 12.34, based off of our units, feet away. The statue is 12.34 feet away. And make sure you are able to do this on your own. This was 10.1. We are about to start 10.2. So I would like you to take the next 4 problems, 2 through 5, and plug them into your calculator. And you're going to notice something, specifically with 2, 3, and 4, 5. So when you plug them into your calculator, sine of 40 is about 0.64, and sine of 140 is also about 0.64. Interesting. When you do 4 and 5, sine of 80 is about 0.98, and sine of 100 is also about 0.98. This is going to come into play later, but what you should understand is you could possibly have 2 of the exact same answers. So if we have sine of 40 and sine of 140, we could see that they're both 0.64. You should also see that 40 plus 140 is what? It's 180. Well, this one says 0.98 and 0.98. Well, what's 80 plus 100? It's 180. So the 2 answers are about 180 when added together. So you're going to see later on why that works. So number 6 and 7 is a build-up to what we're going to be learning today, but we're kind of just setting it up so you can see what's happening. So what we'd like you to do is you have big A, big B, big C, little a, little b, little c, and all you need to do is plug them into the formula we give you, right there, sine big A over little a, and then plug it into your calculator to see what you get. So for the first one, sine big A, so big A is 30 degrees, so we have sine of 30 all over little a, which is 1. You plug that into your calculator and you should be getting 0.5. I'm going to do the same thing now, but for B, so big B is 60. So we have sine of 60 over little b, which is the square root of 3. That's going to equal 0.5. Huh. I'm now going to go to sine of C. Again, we have a box, which means it's 90 degrees. So we have sine of 90 degrees all over little c of 2. And when you plug that in your calculator, you're going to see it is also 0.5. Huh. Why are these the same? We'll be getting to that, but interesting. You're seeing how this is going to start working. All right, you're going to do the same thing with 7, but if you notice, 7 is not a right triangle. So we're going to do the same thing, but with 7, with all of that jazz. So sine big A, so sine of 71.6 all over little a of 6. I'm just gonna plug them in real quick. Sine of B is sine of 63.4 all over little b, 5.7. Sine of 45 all over little c of 4.5. So now I would plug them into your calculator to see what you're getting. And what you're getting is, the first one is to be 0.158 approximately, and then the other two are about 1.57 approximately. So they're very, very close. And the reason why they're not exact is because of the decimals and understanding that even though this says 0.6 and 0.4, more than likely it's like 0.37 or 0.37 like 2229. So that's why they're super close but not exact. But it works for non-right triangles, which is a key concept of what we're going to be learning today. So we're going to look at our essential question of when and how do I use the law of sines. So first we need to understand when we label triangles, capital letters are used to represent angles. So capital letters like A, B, and C were the angles, and the same lowercase letters are used to represent the opposite sides. So we saw little a, little b, and little c. So they have to represent opposite sides. To solve a triangle, it means you need to find everything. You need to find all missing sides, all missing angles, everything. So you're finding all sides and angle measures. So you have to find everything that has been labeled as a variable or not there or anything. So law of sines works for all triangles. So that's why we're learning it. So that way we don't have to just be like, oh, it's not a right, I can't do it. So to use it, you must know one side and the angle opposite of each other. So what that's saying is if you know big A, you should know little a if you're going to use it. So you have to know that big A and little a are the same, or B and B and C and C. So what this all comes down to is the property of law of sines. So what law of sines says that for any triangle, I can use this formula that says sine of angle A over little a equals sine of B over B, which equals sine of C over C. So it says that for all angles and all sides using this, you can find all missing angles and sides. Again, the reason why you can't do it, you have to use an angle and a side is so that you know this, and then you can find the opposite of another, and you'll see that here in just a second. So, knowing law of sines, we can now solve this triangle, and what we mean by solve this triangle is find all missing side lengths and angles. So first, when you're given a triangle, I know A is a little wonky, we need to put what's been given to us. So we have angle A as 40 degrees, angle C as 22.5 degrees, and little b as 12. Remember, little b has to be opposite of b, so this side is 12. Now that we know what was given, I'm going to start putting in little variables to help us know what's going on. So we do have big A over here, meaning the opposite side has to be little a, and big C, opposite side, has to be little c. And we do not know what angle B is. Well, for us to be able to use the law of sines, we have to know a side length and an angle. We don't know C or A, but we know 12 for B. But we don't know angle B. Well, it's a triangle. So since we know it is a triangle, angle B has to be 180 minus the two already known angles. So angle B has to be 117.5 degrees. So this will help us find the missing side lengths. So if you know two angles, you can find the third. It's 180 minus the two. Remembering that from previous content. So I want to start solving for A. Let's go A. I like A. So now that I know an angle and a side that correspond to each other, I can say that sine of 117.5 over 12 has to equal anything else to help us find missing variables. So I'm going to go with A. So we're going to see that it is sine of 40 over our unknown little a. We just set up a proportion. We're just solving proportions. So we're going to cross multiply. We're going to see that a sine of 117.5 is going to equal 12 sine of 40. To get a by itself, I'm going to divide by sine 117.5. So we know that sine a equals 12 sine of 40 all over sine of 117.5. I'm going to plug that into my calculator. So make sure when you're plugging this into your calculator, you are putting the numerator in parentheses to make sure that happens before the division. So when you plug it in, you should see that A is 8.70 because we are rounding to the nearest hundredth on these. Sweet, that's A. I only have to find C now. And we've solved a triangle that isn't a right one. So knowing again 117 and 12, I am still going to use that. You should always do the ones that are definitely given to you. Even if you have to solve for an angle, that's fine. You know that angle is as exact as possible. But if you start to use A, you're going to have a few decimals that are off because you did have to approximate to 8.70. So now we're going to solve for C. I'm going to set it up the same way. We have sine of 117.5 over 12 equal to our now new sine of 22.5 all over our unknown variable of C. It's a proportion. We solve it the same way. We're going to cross multiply to get C sine of 117.5 equal to 12 sine of 22.5. Divide by sine of 117.5, so C equals 12 sine of 22.5 divided by sine of 117.5. Plugging it into the calculator. Again, make sure your numerator is in parentheses. And you should get that C is 5.18. So you are solving law of sines. You solved a full triangle all by itself that wasn't right. And you didn't have to use SOHCAHTOA in any way. So that is a big, big key thing, okay? So if you have any questions, again, please come and visit me on any meetings, email me, all that jazz. So what we're gonna see here in this next little incident is that combination of two possible answers. So back to that bell work of 2, 3, 4, and 5. So when we're using the law of sines to find an angle, so specifically an angle, there might be two possible answers. And the one the calculator gives you, so the one that you're gonna put in your calculator, it gives you, that's theta. And then there's another one, which is 180 minus theta, okay? So if you remember back on 2, 3 and 4, 5, 4, 5 was sine of 80 and sine of 100. So 80 was the first theta, while the second one was 180 minus 80, which was 100. So for the second angle to work, though, the sum of it and the original angle that's been given must be less than 180. Because if it's more than 180, is it a triangle? So it's just a checking measurement. So we're going to be doing that here for 2 and 3. So for 2 and 3, in this triangle RST, we have S equals 40, R equals 30, and little s equaling 20 with meters. And we want to find all possible measures of angle R. So I don't even need to, you don't need to set up a triangle. Because if you remember, If you know the large S and the little s, you already know those are opposite of each other. So that means these two are going to be together. So we have sine of angle 40 all over 20. It's going to have to equal sine of r, because that's what we're looking for, over our little known r of 30. So again, it's just a proportion. I didn't have to set up the triangle because as long as s and s are together and you were looking for r with an r, you have enough information. So we're going to cross multiply. So we're going to get 20 sine of r equals 30 sine of 40. I'm going to divide by 20, so we have sine of r equal to 30 sine of 40 all over 20. Make sure if you simplify, you can only simplify that 30 and 20. You cannot simplify that 40 because it is inside of sine. Now that we've gotten to this point, we need to find that missing angle. And if you remember finding missing angles, it is the inverse of what you're doing. So we're going to have to say r equals the inverse of sine of everything up here. I personally would not simplify just because it's just easy to plug and chug into your calculator. So when you plug and chug, you go sine inverse. I would do parentheses, another parentheses over the numerator, and then divide by 20. So you're going to see that r is equal to 74, and for angles, you only have to do one decimal. Only one decimal is needed. So r is 74.6 degrees. So we have found r. This is option 1. Option 2, again, says I need to do 180 minus theta. So we're going to say option 2, which is 180 minus 74.6, which is going to equal 105.4. So that is a second option. So we need to check that second option. To check that option, all you have to say is, so this is checking. So we're going to take 105.4 and we're going to add what was originally given. So we were given the 40, so we're adding 40. And we can see that 105.4 plus 40 is 145.4, which is less than 180. So this does work. So you do have two answers where r is 74.6 and 105.4. So this is what we mean by checking. So you only have to check if you are solving for a measure of an angle, okay? So this is when you're given two sides and an angle, okay? So we're gonna do it again with number 3. Same process. Checking to make sure it all works. So now that we're doing this, same process. We have triangle ABC. We have an angle of A side length of A, and then a side length of B. And it says find all possible measures of B. So we have an angle and a side length that correspond to each other, so we can put them together. So sine of 76 all over 12. And it is going to have to equal sine of our unknown B over 4. Same process, okay? So we cross multiply, we're going to see that 12 times the sine of B equals 4 sine of 76. We're going to divide by 12. And then understand when we solve for B, we are solving for the inverse of sine of all of this stuff, okay? So we're going to see that B equals 18.9 degrees. And again, this is option 1, because this is what originally we put in our calculator. And again, numerator in parentheses. And we're going to see that 18.9 works. Again, you don't have to check this one because this one gives it to you. It's a calculator answer. You're good to go. But now we need to see if there is a potential other measurement. So option 2 says we're going to take 180 minus 18.9. And we're gonna see it's gonna get us 161.1 degrees. So this is another angle for B potentially. I don't have to write that. But we have to check it. So to check, we're gonna take 161.1, we're gonna add our original degree, which was 76. When you add the 76 and 161.1 together, you're gonna see it is 237.1. Is that less than 180? No, it is not. So this does not work. Okay? So that's all you have to do to check, is you add what you find from option 2 to your original degree that was given, because that's already a part of the triangle, and you do that one. Okay? We have one more problem. It's a word problem. I know how much you love those, especially after 10-1. So, one more problem. It's a word problem. You'll be all right. It's pretty straightforward. We have 2 scuba divers that are 20 meters apart below the surface of the water. They both spot a shark that is below them. So what I'm going to do is make this as realistic as possible with the triangle. So we're going to say scuba diver 1 here is 20 meters apart from scuba diver 2 here. And they see a shark. So we're going to say they see a shark below them, because remember, this is the water. They're below here. The angle of depression. So remember how I said depression should always have the dotted line? Well, that works almost every time. Here is the exception. The reason why this one's not going to need the dotted line is because our horizontal is already at the top. So this means that our horizontal is in the place of the dotted line. This is the only time depression is going to be inside the triangle, when your horizontal is at the top and not the bottom, which you're used to. So the angle of depression from diver 1 to the shark is 47 degrees. And the angle of depression from diver 2 is 40 degrees. How far are each of the divers from the shark? So what I'm going to say is between the shark and scuba diver 2 is our X, and the shark from shark 1 is our Y. Okay? So just X and Y, just random, 2 little different things. So we need to see how far each of the divers are away. So for us to use law of sines, again, remember we have to have a degree and a side length. Well, we have a side length and 2 degrees, meaning for our angle shark, we need to take 180 minus our known angles we were given. And that's going to say 93 degrees. So our angle here for the shark is 93 degrees. Now we have enough information, because we have a side length and an angle, to be able to find X and Y. So we're going to solve for X first, because I like alphabetical order. We're going to see that sine of 93 all over 20 is what we're going to be proportioning it to. If we're looking at X, we're going to be looking at scuba diver 47 degrees over our X. And it's just a proportion, so we're going to cross multiply to get X sine of 93 equal to 20 sine of 47. Divide by sine of 93. And we're going to see that X equals 14.647, and we were in meters, so meters. So that's how far away scuba diver 2 is, because remember X is from S2 to shark. So now we're going to do scuba diver 1's length, but we have to use scuba diver 2's angle. I'm still going to use sine 93 and 20, because that is, again, what has been given to us. We had to approximate, try not to use approximates. So we're going to do sine of 93 over 20 is equal to sine of 40 over y, and it's just another proportion, just like what we solved. So we cross multiply, we see y sine of 93 equals 20 sine of 40. We divide by sine 93, so we get y equals 20 sine of 40 divided by sine of 93. And when you plug that into your calculator, y is 12.873 meters for scuba diver 1. Away from the shark. If you have any questions whatsoever, please make sure to email me. Anything, seriously, I want here to be to help.